Welcome to the Rise Inside podcast, hosted by Justin Starbird and powered by RISE Robotics. Listen as host Justin talks to experts from the RISE team about topics relating to mechanical engineering, industrial design, commercialization, and innovation. True collaborations work when ideas are integrated at inception to solve significant problems. Rise Inside brings together how the team continues to work with great folks to commercialize ideas. You're listening to the Rise Inside podcast. Here's your host, Justin Starbird.
Welcome back to this episode of Rise Inside. My name is Justin Starbird. Today, I am fortunate to be joined by Ken Gray, Vice President of Business Development, and Blake Sessions, Chief Technology Officer at RISE Robotics. Guys, welcome. Thanks for joining me today.
Thanks for having us.
Thanks for having us.
Blake, I'll start with you. You joined RISE several years ago as part of the founding group that created RISE, and I've heard of conversations while you were still at MIT and graduating, and meeting some of the other members of the team in Tomas, how you and Aaron got involved. But tell me, what is RISE?
What is RISE? I mean, I think it's as a group, to talk about the group first, and then I guess myself second. As a group, we just love efficient, effective machine design, and we're here to reimagine how machines are designed from an architectural perspective, from a usability perspective, from a how does the machine actually operate and what does it do and how is it monitored, and from an ergonomics perspective, from in Kyle's case, a visual perspective. He's all about making things look better, and there are a lot of industrial machines that just look industrial, for lack of a better word.
Yeah.
But I think all of us, our energy kind of centers around making machines that are just beautiful, to use, I think, a word. And one of my contributions to that, or my main kind of drive or motivation behind that, is I have always been fascinated by biomechatronics. I'm someone who studies biomechanics, in other words, the mechanics of the body and of natural anatomy. And biomechatronics is kind of like how to apply that and how to interact with that. So I worked on exoskeletons and orthoses and prostheses in college, and I really just came to love it in a way that I didn't expect. And ever since then, I've been trying to focus on the kind of key mechanical interactions that make things move, and really, not just looking at a hydraulic cylinder and saying cylinder, but looking at, the tiny micro interactions within a gear pump and sort of what that means in terms of efficiency and how all those little individual pieces, work together. And we've been at it for quite a while, as you have probably heard. I think some would characterize us as an independently funded MIT research lab. And that's kind of what we were doing for a long time before we hit upon a few theses that really work, that are practical and believable and have a truly enormous impact. So, it started with wearable machines, in part because that's what I was working on at school. And obviously I wasn't trying to step on any toes as far as the machines were present at MIT in the labs that I worked on, and that wasn't really my point. I was instead looking at how to make recreational versions, and I think Aaron and I especially got really jazzed about the notion of just wearable, fun recreational machines, particularly in like urban circumstances.
I heard a lot about some of that today, and the start, of that. I know that there is an intersection point there where you decided to get away from, the personal wearable, projects and go and solve, more of it, or realizing that there is a need for components in the industrial sector. Tell me a little bit about how that happened.
So I think that came down to, it was an interesting kind of transition. It started with trying to make these wearable machines, and it turns out that, I mean, you've probably seen all of us have seen exoskeletons of various kinds made by companies, and they're almost as clunky and hilarious as those that are presented to us in science fiction. I mean, not all of them presented to us in sci-fi or that, but a lot of them are. And it just turns out that it's really hard to design a machine like that. I mean, it's hard to respect, the body's needs in a sense, like in such direct, close contact with such, close interactions with a person's body. And it kind of comes down to how we as people design things. We have a different attitude and a different approach to make machines work. And I mean, they do obviously work very well in most circumstances, but it's a very high bar to design a machine that is effective and impressive, that also interfaces with the body. And from that requirement came this delving into power transmission systems and sort of how to more efficiently convey power from an electrical source into a structure, and in particular articulated structures was the focus of what we were working on. So out of that came these power transmission methods. And I think it's worth pointing out that, belts, form the core of what we do here at RISE, and tendons and ligaments in the body can be thought of as belts. I mean, they don't rotate continuously, but they do bend and unbend over round surfaces, much like belts do. They're kind of like finite motion pulleys, if you want to think about it that way.
Sure.
So we in pursuit of exoskeletons, we developed, I would say, improved means of power transmission that we then took and basically reapplied back to the commercial sector.
Ken, now your job is to help sell this, right? And create, a market for it, and get that message out there. Tell me a little bit about how you, came to RISE, and how that vision has really, shaped your role today.
Well, first of all, I'm lousy at sales. I'm great at building relationships. So my role really is to foster relationships that through a cooperative, some kind of agreement between those companies and RISE, that we can work together to bring this technology to fruition, to improve a design. So that's really what I do. And I've said many times, the reason that I came to RISE is because I regard RISE, if you ask me what RISE is, it's the intersection of elegant mathematics and practical applications. I really love the efficiency of these of RISE cylinder. There's just nothing out there like it today, and it enables us to take a system view of machines that use hydraulic technology today and apply with the technology that this great team has developed to dramatically reduce the power consumed in that application. It's just it allows us to do some things that, frankly, in my 35 years of developing heavy equipment, we were unable to do, just because hydraulics uses so much power. And the other things, I mean, RISE has a technology that, I mean, it's a fluid-free, electric, passively cooled alternative to hydraulic systems, and it is incredibly light, and its superpower is in high power. So, and I kind of go back to Blake. I'll go back to comic books and sci-fi. RISE's superpower is the ability to transform rotational power, really high power, into translational power, and that there's no one that can do it more efficiently than RISE can right now, and that just enables us to do so many things with heavy equipment. And that's what got me out of bed. That's what gets me out of bed, is the potential of redesigning in a much more elegant way the heavy machines that I fell in love with when I was a little kid.
Well, and it's that power that it's been created. In one capacity, you could argue that it was discovered by mistake, right, Blake?
Yeah, I honestly don't love that phrasing. I might have caught myself saying discover. There are certain pieces of what we do that were discovered by mistake, and I think.
Well, I can rephrase that if you'd like.
No, it's okay. I mean, there's one element of RISE technology was discovered by mistake. I will say that. I mean, there are many others that were not. There were many others that were very intentional. But the one that was the quote unquote discovered by mistake, I was basically designing belted systems that were more topologically complex than are recommended. So usually these belts, this polyurethane steel construction is intended for use in very sort of, vanilla applications where you have a pulley on top and a sort of seesaw action, right? And that's a classic elevator application of this belt. And I think what I was trying to sort of squeeze out of this material system that has these extremely high performance properties was, on the one hand, we have this high performance material, and then on the other hand, we have such like dramatically limited application of this material. And then compared to that, we have wire rope that sees use almost everywhere. So, how can we take this thing, this material that is so tribologically superior, and do more interesting things with it? And that's what led me to design some of the geometries and mechanisms that resulted in the use of twisted belts. And with the construction of twisted belts, I quickly found that they essentially degraded much more rapidly than we had expected. And from there, I delved into the details of why. So I wouldn't quite say it was an accident. I was there with thermal cameras and measurement systems and all sorts of stuff to get at the micro interactions that were causing that rapid degradation of belt in twisted circumstances, twisted spans.
Yeah, there are a couple of really super important words to pull out of what Blake just said, if I can interrupt you here. Understanding why is incredibly important, and that's why it's not, it's hard to say that it's an accident, right? Understanding why belts live the way they do is really the essence of an important element of RISE technology and the IP behind RISE technology. And it's also really important to understand that there are two ways to kill a belt really quickly. One of them is to twist it. And the other way is to sheave it. That is to bend the belt on an axis that's perpendicular to the plane of the belt. If you do one of those two things, you're going to kill the belt, the life of the belt. But to compartmentalize this thing, to get the reduction, to run a belt through a block and tackle, if you will, you've got to do both of those things. You have to sheave it and twist it at the same time. And that's what's incredibly remarkable about RISE technology, is that these guys, Blake, Tomas, and the team, figured out that if you twist it and sheave it at the right ratio, and I'm oversimplifying here tremendously, you can get great life out of these belts. And that formed formed some of the key patents that RISE technology owns. Sorry, I just think that's such an important concept, Blake, understanding the why things behave the way they do. And that's the elegant mathematics in my mind. It's the explanation of why things work the way they do that have allowed this great team of engineers at RISE that understanding of why to take that into great practical applications of the tech. And it's just such a really important concept for me, the why, your explanation of the discovery and how it works.
Yeah, I agree completely with what you're saying. One small word correction, fleeting. So fleeting is when you misalign a belt. A sheave is the pulley that it runs on.
Yeah, sorry. You're right. Absolutely.
But I completely agree with what you said. It wasn't an accident. It was a design that was initially constructed that didn't work, and we delved into great detail as to why it didn't work, and we looked at the micro interactions of what were causing things to not work, and we made corrections.
Yeah, right.
Which is all in lines of what you're saying. It wasn't just like we happened to kick over a can and like technology fell in our lap. It's not really
Yeah, I've got to take this long thing and jam it into a box like this. How do I do that? And that led to an understanding of how to fleet and twist the belt at the same time to
Right.
get it into that package and make it live for an incredibly long time. And I think that's just an amazing story. Yeah, it's I'm my vocabulary. I'm having a senior moment on a Friday afternoon, but that's it. That's a really great story for me. And that's why I'm here, Blake. That's why I'm here. I just love the elegance of that understanding and translating that into a practical application that's so much more efficient than anything we've been able to do with hydraulics to this point.
Yep. Yeah, and it really, so our designs are not. Nobody's going to tell you, Justin, that they're exactly as compact as hydraulic systems. They are a little bit bigger. They're close enough to work in a lot of circumstances. But one of the big benefits that our powertrain designs convey to people, and I guess also, well, let's say convey to the designer, that's the phrase that I like to use, is the ability to put the power unit elsewhere. So if you have a screw-based system, you basically have to put the motor and the gearbox on the screw, and you'll see actuators powered like that everywhere. You'll see, a cylinder, and if it's hydraulic, then you'll see some hoses running off it because they're doing the work behind the scenes. They're putting all the ugly stuff elsewhere basically, and they're transmitting power to that cylinder with hoses.
Right.
For electromechanical actuators, typically screw-based, you'll see the motor and the gearbox typically, or in some cases, just a short belt reduction on the screw itself, which is great for a lot of reasons. It means you can convey power to that actuator electrically, which is really easy for a variety of reasons. But we kind of get the best of both worlds. We can convey power electrically 90% of the way, and then place our belt power unit in a location that is very close to where power is delivered, but may not be exactly on the cylinder. In some cases, it might be exactly on the cylinder, but other cases it might be close, but still spanning 1 or even 2 degrees of freedom. And then we can take that last little bit of power transmission, kind of like thinking about tendons in your arm, and make that also belt driven to delay power to the point of contact. And that is a thing you simply cannot do with a screw, unless you want to add some belted system that does something similar on the way to the screw, which that kind of defeats the purpose of the whole thing.
Right.
So we have this nice flexibility where we get the best of a lot of different worlds, and it's a little bit different, right? I mean, but it carries similarities and sort of analogs to both particularly to hydraulic systems, but also to screw-driven systems.
Well, and you solving that and creating the power structure that you have has led to some pretty unique industries. I'm sitting in your office, ironically, and
we're not.
Yeah, overlooking a construction site now. There's a delivery being taken place using a truck that has a lift gate in it, and I'm overlooking the lab where you're testing so many of these different applications. Tell me a little bit about the partnership that was created as a result of you being able to solve that power structure.
Sure. So we are very fortunate to have a partner in Anthony Lifgates. We really admire their entire team. All of them that we've gotten to work with, it's been just an absolute pleasure. And I mean that. And I think they came to visit us basically when the technology was even younger than what you see in the lab behind you. They saw basically just they saw a version of our cylinder that wasn't even packaged yet. So it was essentially like the right drivetrain, the right power transmission system, but it wasn't even packaged in the cylinder. It clearly wasn't going to fit in any lift gate. And they saw that and they were like, you know what, let's give these kids a shot. I guess they're not kids anymore. Let's give these guys a shot. So
it depends on, it's all about your perspective, Blake. Let's give these kids a shot. Sorry. Yeah, but yeah, it's a great story.
This is the only interview I've done with video today. So Ken, your perspective is the one that, it makes us feel younger.
That's that's it should, as it should. Sorry to interrupt. I just couldn't stand it. I had to jump in there.
Yeah, so they they weren't going to just write us a check at that point in time, and they shouldn't have. They saw a drivetrain picking up, raising and lowering 2,000 pounds, which was the act of it was impressive, startling, whatever the word. It was unexpected, right? And they thought there might be some promise to this, but instead of just walking away, they said, hey, let's give these guys a shot, and so they gave us their machine, and by giving us one of their stock hydraulic machines. They gave us the opportunity to show them that we really could make this thing work, in real life. And that alpha liftgate that is not currently anymore in our lab, but was for a very long time. It's packaged in a way that is very close to what hydraulic packaging is capable of doing. In fact, arguably, it's much better because there's no hydraulic box. So the total volume of the product is significantly less than a hydraulic system when you include the hydraulic power unit, the hydraulic box. In the envelope of the system. And if you want to see a nice comparison of that, Kyle has I could probably dig it up too, but I think going to Kyle is the best way to go. He has a picture of the hydraulic box and how it's been compressed into what we've called the quote unquote electric pump box, which is a rough analogy, but the point is they gave us their machine and we made it work. And once we showed them that we could retrofit our power transmission system into a liftgate, they're like, all right, off to the races. Let's productize. Let's make this thing happen. Let's bring it to market. And it certainly required a lot of faith on their part. They're really good at a lot of things. I mean, they're a real American manufacturer. They purchase sheets of steel and they turn them into liftgates. I mean, it really is it's really impressive what they do, and they really do make an American-made product. And so we're just thrilled to partner with them to bring something that is powered in such a modern way, combining it with that base of I don't even know what the word is here, but it just, it's a good partnership for a lot of reasons, and that, we're just excited to be doing it.
There's a really interesting legacy of invention at Anthony Liftgates. I mean, they're arguably the inventors of the first power liftgate. And so one of the things that's very exciting to us is now with them, we're reinventing the power liftgate. And so we view this as simply a continuation of their innovative, inventive culture and an extension of where they were born.
And what kind of advantage does this give Anthony? And then what does it give you as you continue to seek out industries to innovate in?
So I think to look at the impact that it has on the liftgate first, I mean, I think it's important to note that the benefit that our power systems bring varies depending on what machine we're talking about. So some companies, all they care about is fluid leakage. If they leak hydraulic oil into the concrete foundation, that costs them X number of dollars over the course of a year, or it's not even accepted, but so it can sometimes be all about fluid prevention. That's not the case with the liftgate. They didn't come to us with an ultimatum to get rid of all fluids, or else they couldn't sell liftgates. That's not an issue for them. But they did come to us with many issues around maintenance, around efficiency, and around sort of uncertainty of machine management. And so I think I would characterize the main benefits of our liftgate as being efficient. So it's energetically efficient first and foremost. I mean, it saves 75-80% of the power that is used when compared to a hydraulic gate. It's kind of like starting your car continuously for 30 seconds and then driving down the street and then starting your car again for 30 seconds and then driving down the street and doing it again and again all day long. So they have power problems that manifest in different ways, in dead batteries and service calls, and just people put solar panels on these trucks to try to keep the liftgate charged. I mean, it's crazy the lengths that people are going to simply compensate for what is effectively an inefficient power transmission system. So that's the big benefit. But there are other ones too, and I think the biggest one in my mind is the fact that it's basically self-managing, and it's just by virtue of the materials that we employ and the way that we use them, we're able to monitor the machine's performance in a way that you simply can't do with hydraulic systems. You can't assess the condition of a hydraulic seal within a rod, dynamically over the course of the life of the liftgate. You don't have a microscope that is sitting there inside the hydraulic cylinder that is looking at that seal, and they will run for many years, but when it goes, right? And same thing goes for hoses. Hoses are notoriously difficult to monitor and to keep track of the condition of that hose. And as a result, you have either people who you have operators who replace the hoses on a sort of proactive basis, where they just replace, if the mean time before failure is 9 months, they will replace it every 3 months, right? So just as an example, or you have operators who just neglect them and let it fail, and kind of, the see what happens game. And we have neither of those things. We have materials that are managed and used and can be monitored and recorded and assessed for their condition at all times, which is key, because it means that assuming we do our jobs well, there will be no unplanned downtime. There will be no wasted costs associated with proactive maintenance. We'll maintain it exactly when we need to. So that I think is actually the biggest benefit of all of this is we have machines that are essentially self-managing, right? So there's no person that has to come in to assess the condition of a thing. The condition is automatically assessed, by the powertrain itself, by our cloud IoT system, sort of industry 4.0 system that we're putting into place to take information from the machine over a cellular antenna, and it's self-managing. And that kind of correlates with the third sort of related benefit, which is it's really easy to simply swap in a new cylinder. We've done it hundreds of times. I don't know if we want this information to be public, but we've been doing it a lot while we debug our stuff.
During the development process. Yeah, that's normal.
Yeah, during development, we've had to take in and take out and put in those cylinders a number of times, and it takes minutes. You couldn't do that with a hydraulic system. It's just because it is fluid based. There's no way in hell you're going to extricate a hydraulic cylinder from its context, replace it with a new one or the same one, and bleed the system, get rid of all the bubbles, like refill it, deal with the mess in minutes. It just isn't going to happen. And that kind of just relates very fundamentally to the benefits of electrical power transmission. And we are not uniquely capable of providing electrical power transmission to cylinders. I mean, again, you could take a ball screw and electromechanical actuator and do the same thing. But when you combine that with the other benefits of what we're doing, I think you're going to see a lot more electrical power transmission with what we're doing as compared to with what screws can do, if that makes sense.
Absolutely.
Yeah, and I think you should forget this. I want to go back to that simplicity topic again. One of the things that's a real benefit here is with the simplicity of the electric pump box. I love that phrase for this thing. It's so much simpler to install. I mean, because what happens is it's usually a truck body manufacturer that installs the liftgate, but we've made it much simpler to do. It's a much easier system to install. The space claim is much smaller because there's no hydraulic fluid reservoir, no pump, none of that stuff. So it's a much easier system for them to install. And then I think the other thing, Justin, is not only are we consuming less power with this, but as the liftgate lowers the load to the ground, we're actually generating. We're charging the battery. We're not depleting the battery in this application. We're charging the battery in this application. So this is the first self-sustaining liftgate in the world. It's going to charge itself.
And I think that is an important component of all this, is that, in a mature industry, you're disrupting, a portion that has been unchanged for years and years. And I think that part is so cool to be part of that process and that vision. So, I'm really excited to see, what's next for RISE as well. I've heard rumblings and of different things here. So it's really, really cool to get your perspective, Blake, and Ken, hear your insights as well, to know what's really inside RISE. So RISE inside is pretty cool. So
obviously we agree. It's a lot of fun. it's a lot of fun to be part of this team, and I'm just honored they invited me to be a part of it. So it really is a lot of fun. It's been a very exciting time to be part of the RISE team.
And we're grateful you're here, Ken, because figuring out how the machine that is industry and how its mechanics operate within supply chain and management and all that stuff is just thank you. It's challenging stuff.
Did you hear him say how great it is to have an old guy on the team there, Justin? Did you hear that? I did.
You can have it recorded, so there you go. This is blown out worldwide.
That's fantastic.
That's the part that'll go viral, didn't you know?
These guys are really, I tell you, they are keeping me young. I mean, it's, this whole concept, you got to be comfortable being the stupidest person in the room to be a leader. Well, I'll tell you what, buddy, you hang around this team for a while and it's pretty easy to be the stupidest person in the room. And if you're not comfortable with that, you need to go somewhere else. I mean, it is a really bright group of engineers. Really exciting to work with them, and I mean that. I just mean that from every fiber of my being. They are really exciting to work with. It's a lot of fun.
Well, I appreciate both of your your time today. It's been great being here in Somerville, just outside of Boston. Meeting the team and looking forward to doing a whole lot more of this, guys. So thank you very much.
Thanks, Justin. Really appreciate
Thanks,
it.
Justin.
All right.
You have been listening to the RISE Inside podcast, presented by RISE Robotics. On behalf of our guest today and host Justin Starbird, thank you for listening. Please share your feedback on our LinkedIn page, linkedin.com/company/RISE-robotics.